ZXLD1350 High Power LED Driver, ZTech Semiconductor. Welcome to this training module on ZTech's High Power LED Driver. This training module overviews the ZXLD1350 LED driver, its basic operation, and key functions. ZTech Semiconductor's ZXLD1350 is a switching regulator. Requiring a single external resistor to accurately set its output current, the ZXLD1350 dramatically simplifies high-power LED driving. Operating from an input supply between 7 and 30 volts, the driver can produce an adjustable output current of up to 350 milliamps to support an LED chain of up to 8 1-watt LEDs. By integrating a 30-volt NMOS switch and a high-side current sensing circuit yielding a plus or minus 4% precision current control, the ZXLD1350 needs the support of a total of just 4 external circuit components. Depending on the type and value of the external components used, the LED driver can achieve efficiency as high as 95%, which combined with low typical shutdown current of only 15 microamps ensures the device offers good power economy and extended battery life. The PWM filter within the chip provides a soft start feature by controlling the rise of input and output current. The diagram illustrates the internal functional blocks of the ZXLD1350. It has 5 pins: LX, ground, adjust, iSense, and VN. The device contains a low-pass filter between the adjust pin and the threshold comparator, and an internal 200k ohm current limiting resistor between the adjust and the internal reference voltage. This allows the adjust pin to adjust output current. The output of the low-pass filter drives the shutdown circuit. When the input voltage to this circuit falls below the threshold, the internal regulator and the output switch are turned off. The 2 internal comparators enable to control the 2 NMOS switches respectively. The ZXLD1350 driver is designed for driving single or multiple series connected LEDs efficiently from a single source higher than the LED voltage. Here lists the application areas where this driver can go up to 350 milliamp current, like low voltage halogen replacement LEDs, automotive lighting, industrial lighting, and LED backup lights. Here is a typical application of the ZXLD1350 driver. The device, in conjunction with coil L1 and current sense resistor RS, forms a self-oscillating, continuous mode buck converter. When input voltage Vn is first applied, initial current in L1 and RS is 0, and there is no output from the current sense circuit. Under this condition, the negative input of the internal comparator is at ground and its output is high. This turns NMOS switch on and switches the LX pin low, causing current to flow from Vn to ground via RS, L1, and the LEDs. When the NMOS switch is off, which switches the LX pin high, the current in L1 continues to flow via D1 and the LEDs back to Vn. The current decays at a rate determined by the LED and diode forward voltages to produce a falling voltage at the input of the comparator. When this voltage returns to V-adjust, the comparator output switches again. This repeats the cycle. This slide shows some operating waveforms. Peak-to-peak ripple current in the LED can be reduced by adding a shunt capacitor, CLED, across the LED as shown. A value of 1 microfarad will reduce nominal ripple current by a factor of approximately 3. Proportionately lower ripple current can be achieved with higher capacitor values. The capacitor will not affect operating frequency or efficiency, but it will increase startup delay by reducing the rate of rise of LED voltage. The nominal average output current in the LED is determined by the value of the external current sense resistor RS connected between Vin and I sense. The adjust pin can be driven by an external DC voltage as shown to adjust the output current to a value above or below the nominal average value defined by RS. Note that when driving the adjust pin above 1.25 volts, RS must be increased in proportion to prevent the I out DC from exceeding 370 milliamps maximum. The output current can also be adjusted by PWM control. Figure 1 illustrates the PWM being applied to the adjust input directly to control the output current to a value above or below the nominal average value set by resistor RS. The recommended method for driving the adjust pin and controlling the amplitude of the PWM waveform is to use a small NPN transistor as shown in Figure 2. Figure 3 shows another possibility by driving the device from an open drain output of a microcontroller. The ZXLD1350 has a versatile adjust pin that can be used in many ways, such as to adjust the brightness of an LED by controlling LED current. Low-frequency dimming is preferred since the LED instantaneous driving current is constant. The color temperature of the LED is preserved at all dimming levels. Another advantage of low-frequency dimming is control down to a 1% level, resulting in a dimming range of 100 to 1. High-frequency dimming is preferred if the system requires low radiated emission and low input-output ripple, but doing so reduces the dimming range to 5 to 1. The ZXLD1350 has an internal low-pass filter which integrates the high-frequency PWM signal to produce a DC dimming control. If the PWM frequency is higher than approximately 10 kHz and the duty cycle is above the specified minimum value, the device will remain active and the nominal average output current will be proportional to the average voltage at the output of the filter, which is directly proportional to the duty cycle. The LED driver has two additional functions, shutdown and soft start. The output of the low-pass filter drives the shutdown circuit. When the adjust pin is set to a voltage below 0.2 volts for more than approximately 100 microseconds, the device will turn off and the supply current will fall to a standby level of 15 microamps nominal. The device has a built-in soft start circuit due to the delay through the PWM filter. An external capacitor from the adjust pin to ground will provide additional soft start delay in two ways, by increasing the time taken for the voltage on this pin to rise to the turn-on threshold and by slowing down the rate of rise of the control voltage at the input of the comparator. The ZXLD1350 calculator is a tool for estimating the performance of the ZXLD1350 in various applications. It allows the effects of different external component values to be evaluated easily, saving both time and cost compared to full circuit simulation or physical construction.